questions 5 through 7 of the 2000 grade 11 Euclid math contest. In the diagram, AD is equal to DC, sine of angle DBC is 0.6, and angle ACB is 90 degrees. What is the value of tan of angle ABC? So here is our diagram, and let's label what we know. We know that AD is equal to DC, so let's call those X. X and X like that. We know that ACB is 90 degrees, and they put that in there, right there. That little symbol is 90 degrees. And what else do we know? I think that's it. They don't give us much more. But we can label this angle, because that angle, they've given us a relationship with sine. Sine of that angle, DBC, is equal to 0.6. So DBC, I'm going to call that theta 1. All right? Theta 1, like that. And do we need anything else? If we do, we'll add it later on, but I think so far we should be okay. So now let's work with this sine theta is equal to 0.6. If that is true, then that means that the opposite over the hypotenuse is 0.6 for theta 1. Well, this is the opposite right here, x, and the hypotenuse is right here, BD. So let's give that some value. Let's call it h. H for hypotenuse. So that essentially means that the sine of theta 1, which is 0.6. And how do you figure out sine? Opposite over hypotenuse. So in this case, it would be x over h is 0.6. And therefore, x is equal to 0.6h. All right, just simple from that. Now we will introduce a second variable right here, BC. BC I will call y. And when I do that, I'll be able to figure out a Pythagorean relationship in the triangle BDC because we have a right triangle. So that relationship is y squared plus x squared is equal to h squared, like that. And therefore, y squared is equal to h squared minus x squared. And y squared is equal to x squared minus x we know is 0.6h. We just figured that out. Squared. So therefore y squared is equal to h squared minus 0.36h squared. And this looks like 0.64h squared is equal to y squared. If you take the square root of both sides, this will become 0.8h. So now we have another relationship. All right? So what do they want us to figure out? Tan of ABC. So ABC, tan of this angle. All right? Tan of that angle, ABC, is equal to, how do you figure out tan? It's opposite over adjacent. So opposite would be this whole thing right there, which in our case is 2x. And the adjacent is right there, which is y. And we have both x and y in terms of h. So this becomes 2 times 0.6h from here. And the denominator becomes right here, 0.8h. And this looks like 1.2h over 0.8h. The h's cancel, and you just get left with 1.2 over 0.8. And this is 1.5. And if you want to write it in terms of a fraction, 3 over 2. So there you go. We just found the tan of ABC. On a cross-sectional diagram of Earth, the x and y axes are placed so that 0, 0 is the center of the Earth. C 6.40 is the location of Cape Canaveral. A space shuttle is forced to land on an island at A 5.43, 3.39. As shown, each unit represents 1,000 kilometers. Determine the distance from Cape Canaveral to the island measured on the surface of the Earth to the nearest 10 kilometers. Okay. So I'm going to draw this out instead of reproducing it or blowing it up, because I'm going to need to label some things. So here's our coordinate, and we have to draw in that circle like that, and we have to now point to A. So that's going to be A, and we can label this now. We've got 0 here at the center. Right here is C, 6.4 and 0, and this point is A, which they've given us at 5.43 and 3.39. All right, so what can we do? Well, the first thing I want you to understand is, what do they want us to figure out? Determine the distance from Cape Canaveral, which is C, to the island, which is at A. But they do not want a straight line. So don't make that mistake, because you might think, okay, A to C is a straight line, let's figure it out. No, they want it, and they even tell you in the question, on the surface of the Earth. So what they are looking for is this distance right here, on the surface of the Earth. Okay, keep that in mind. So how are we going to do this? Well, since they want a portion of the circumference of the circle, we need to work with the circumference of the circle. So what is the circumference of the circle? It's always equal to pi times diameter, and the diameter, of course, is equal to 2 times the radius. Do we know the radius of this circle? And the answer is yes, we do. Right here, from here to there, is the radius, and it's 6.4. So circumference is going to be pi times 2 times 6.4, like that. And this becomes 12.8 pi. Now what we need to do is figure out what is this angle. If we can figure out that angle, theta, then we will be able to figure out the distance on the surface of the Earth from A to C. So how do we figure out that angle? We need to figure out a relationship between A and the base there. I drew a little right triangle like that. This is a right triangle, and that will give us our relationship and help us figure this out. So now, what is the distance from the origin to there? Well, that's just the x-coordinate, right, of A. So that's 5.43. 5.43. And then how about here, the distance from there to there? Well, that's the y-coordinate. So that would be 3.39. Not drawn to scale, but don't worry about that. And I think that's it so far, because we are interested in the angle. 2 sides is enough to figure out the angle using trigonometry. So what do you want to use? Tan. The tan of theta is going to be opposite over adjacent. So 3.39 over 5.43. And therefore theta will be approximately 32 degrees. Like that. Okay? So now we have to figure out the area of this segment of the circumference. And how do you do that? Well, that's where the angle will help us. 32 degrees is our angle, and the total angle all the way around is, of course, 360. So this will give us the proportion of the circumference. And the total circumference is right here, 12.8 pi. So 12.8 pi is the total, and our segment, which I'll call, well, it's AC. We'll call it arc AC, like that. So let's solve for AC arc. So this looks like it will be 32 times 12.8 pi, all divided by 360. And if you do the math, it comes to about 3.57 approximately. Now 3.57 is not the answer because each unit represents 1,000 kilometers. So we have to multiply this by 1,000 kilometers. So 3.57 times 1,000 kilometers, because each unit represents 1,000 kilometers. And this becomes 3,570 kilometers. And that is the answer that they are looking for. So that takes care of number 5. Let x, with these strange brackets, represent the greatest integer, which is less than or equal to x. For example, bracket 3 is 3, but bracket 2.6 is 2. If x is positive and x times the bracket x is 17, what is the value of x? So they've got this operation that gives you a certain value, an integer value. Now, what I'm going to do is I'm going to introduce a number. I'm going to call it, say, anything, but I'm going to use, say, 2.6. And I'm going to explain this. So if you take the bracket of x, first you get the integer part, and that's all you get, right? And I'm going to let a equal the decimal part. So in this case, it's 0.6. So that means that x essentially is the integer part plus the decimal part, right? Does that make sense? So x in our case was 2.6. The integer part is 2, and the decimal part is 6. So this all matches. So this is basically how you think about this operation. So if you isolate for the bracket part, like this, it becomes x minus a, like that. All right? So now they're telling you that they've got this relationship, x times x bracket is 17. So they're saying that they've got x times x bracket is 17. All right, so that basically means if we use our new relationship there, that x times x minus a is equal to 17. You've got some number x, and then you're going to subtract from it the decimal part and multiply them together, and you'll get 17. Well, so this is really an inspection type of question. There's no magic quadratic formula or something like that. You might be tempted to do that, but this is just inspection. Think about this. The first thing I did in my mind was I thought, okay, you've got two numbers multiplied together. One is an integer and one has a decimal component. What is the square root of 17 approximately? It's about 4 something, 4 point something, right? 4.1 or 4.2. So these numbers have to be sufficiently close to 4. So I'm going to have something like some number, which is the integer part, which is this one right here, is going to be 4. And then I'm going to have 4 point something. That's basically how it is, right? Keep in mind, this is an integer, and therefore x minus a is an integer, and that's why I put 4 there. And if you do this, you'll very quickly solve it, and you'll be able to figure out that this number is 4.25. All right? It's one of those inspection questions. You just have to look at it, kind of intuitively figure out what is the number closest to, and then you'll be able to solve for x. So x in this case is equal to 4.25. And you can verify this, right? If you have 4.25 as x, then what would be the value of this expression? Well, let's put that in there. This expression is x times bracket x. X is 4.25. Bracket x is just the integer part of it, which is 4. And 4 times 4.25 is indeed 17. All right? So x is equal to 4.25 is the answer to part A of 6. The parabola y is equal to minus x squared plus 4 has a vertex at P. So that is right there. Y is equal to minus x squared plus 4. It intersects the x-axis at A and B, as shown. The parabola is translated from its original position so that its vertex moves along the line y equals x plus 4 to the point Q, right there. In this position, the parabola intersects the x-axis at B and C. Determine the coordinates of C. Okay, so remember, any parabola has this form: a x minus h squared plus k. And the vertex is represented by hk. That is the standard formula of a parabola and its vertex. Now, we are given a parabola y is equal to minus x squared plus 4. So let's first figure out a, b, and p, and then we'll move forward with the rest of the question. So y is equal to minus x squared plus 4. So if we set x equal to 0, we should be able to get the coordinates of p. So if x is 0, we have y is equal to 4. All right? So p, the coordinates, and the way they've drawn this for us makes it easy. Since p is right on that y-axis, we got 0, 4. That's the coordinates for p. All right? So now we have to figure out the coordinates of a and b. This one and this one. Well, what are a and b? A and b are essentially the x-intercepts. So to figure out the x-intercepts, you set y equal to 0 in this formula. So that gives you minus x squared plus 4. X squared is equal to 4, and therefore x is equal to plus or minus 2. So this a is minus 2, 0, and this b is 2, 0. Okay, so that's pretty straightforward. Now let's turn our attention to the rest of the question, which is now you're moving this parabola along this line so that the vertex now becomes at Q. Okay? So now this is the second part of the question. Once you translate the parabola, it will move according to the way they've shown it. And the only thing that changes is the vertex, right, in this equation. But the coefficient A will not change because you're not stretching it. You're not pulling it apart or narrowing it. You're just moving the vertex. So if you write the equation of the new parabola, which is right here, it will be y, and the coefficient A will not change. What is A in our original formula? Minus x squared plus 4. A was negative 1. So it's still going to be negative 1. But what does change, of course, is the vertex. So our vertex is now going to be HK. We don't know the vertex yet, so I'm just putting HK. All right? Now, when we had the parabola in its original position, the vertex was 0, 4, right there at P. But now I've translated it and I've put it in this form, and therefore our new vertex is HK, like that. And that's basically point Q. So this basically just becomes minus x minus h squared plus k. All right? Now the good news is that HK is on this line right there. Q is on that line. So any point that's on that line, we can substitute into this formula. So this basically means if the x-coordinate is h, we can plug h into here to get the y-coordinate. So the y-coordinate would be h plus 4. So I hope that makes sense. So instead of using k, I can use h plus 4. So I've got y minus x minus h squared plus h plus 4, like that. All right, so let's work with. Now at this point of the question, let's backtrack and try to figure out what it is that they want us to calculate. They want us to calculate the coordinates of C right there. And since we have this equation, we can do that, but we would probably need to get the value for h first. And how do we do that? Well, the good news is that point B will help us. Point B is interesting because it's on our new translated parabola. You can see that from the graph. It was on the original parabola, and that's how we were able to figure it out as 2, 0, but it's also on the new parabola. So that coordinate 2, 0 will also be able to be substituted into our new equation, and that should help us figure out C. So let's substitute that in. We got 0 is minus 2 minus h squared plus h plus 4, like this. And this gives us minus 4 minus 4h plus h squared plus h plus 4. And this looks like minus 4 plus 4h minus h squared plus h plus 4. 0 is equal to, well, these cancel, these 4's, and we have 3, or rather 5h minus h squared. And this can factor h 5 minus h, and therefore h is equal to either 0 or 5. Correct. Let's go back and see if it's 0 or 5. Well, h obviously from the graph can't be 0. It's got to be therefore 5. So h equals 5 is the only acceptable solution. All right, perfect. We are almost done. Our equation therefore becomes y is equal to minus x minus 5 squared plus 5 plus 4. And now we can figure out C. C was a x-coordinate. So to figure out an x-intercept, I should say, C is an x-intercept, we set y to 0. And that will be able to give us the coordinates for C. So 0 is equal to minus x minus 5 squared is equal plus 9. So that means x minus 5 squared is equal to 9. And therefore x minus 5 is equal to plus or minus 3. X therefore will be either 8 or 2. Go back to our graph. Well, it's not 2 because this is already 2, so therefore this is 8. And because it's on the x-axis, it's an x-intercept. The y-coordinate will be a 0. So there you go. 8, 0 is the coordinates for C, right there. (7a) A cube has edges of length n where n is an integer. 3 faces meeting in a corner are painted red. The cube is then cut into n cubed, n to the power of 3 smaller cubes of unit length. If exactly 125 of these cubes have no faces painted red, determine the value of n. All right, so first let's explain the question. I will first draw a cube. And what they do is they paint the entire cube is going to obviously have 6 sides, but they are only going to paint 3 faces. All right, so the 3 faces that you currently see, those are the ones I'm going to paint red, like that. Okay, and therefore these ones are the ones that we are most interested in. Now they don't give us any values, they just say that it's n. And it'd be helpful if it was 10 or 20, but they don't say, they just say it's n. So these sides have length n. All right, that's fine. And then what they're saying is that they're going to cut all these into smaller cubes of unit length, meaning length 1. So basically, they're going to make a cut like this and going down like that. You see what I mean? And then they're going to make another cut, and they're going to make several of those cuts. And that will eventually break up the giant cube into small unit cubes. Okay? And then they're finally asking if exactly 125 of these unit cubes have no faces painted red, determine the value of n. So what we can do is kind of work backwards and say, they're asking for no faces painted red. They're saying 125 have no faces painted red. What we can do is figure out how many do have a face painted red. So that is what we're going to concentrate on. We're going to concentrate on trying to figure out how many do indeed have a face painted red, and then we'll compare it to 125. So I drew the cube again instead of making the one that I already drew a little bit more messy. And we are painting it all red like this, okay? Just the 3 faces that I currently see. Okay, so now I have a cube with 3 faces painted red. Now when you slice them, you will be able to see that only a certain number will have a red face. So this is what I'm going to do. Make it obvious here. I'm going to cut first a slab at the top. So that's the first slab that I'm going to chop off at the top. And then the second one is going to be down like this. And then the third one is what is remaining. So those 3 slabs I'm going to draw over here so you get an understanding of what they look like. So here are those 3 slabs. The first one was the top one, and it has n, and 1, because remember these are unit lengths, these little cubes. The next one is this one, and that one is going to have n here, but n minus 1 and 1 like that. And finally, this one was that one on the side, and that one is going to have n minus 1 and n minus 1 and of course 1. Those are the dimensions of the 3 slabs that I have cut. And if you look at it, once you cut these out, these are the only pieces of that cube that are colored red. And that one is colored red like that. This one, this whole face is colored red. And this side. And this one, just this side would be colored red like that. That's it. The rest of the cube has no red now. None whatsoever. Okay? So now that we've got the diagram illustrated, we can proceed with the mathematics. The total number of cubes, if you were to break this up, is, of course, n to the power of 3. And I think they even tell you that. Yeah, they do. That's the total number of cubes. And the ones that have red anywhere painted on them, one face or somewhere, two faces, is going to be figured out with our three diagrams. The first is going to be n squared, this one right here. The next one is n times n minus 1. And the third one gives us n minus 1 times n minus 1 as the number of red cubes. So the number that have no red is the total minus the red, would be no red. So the total is n cubed, and our red is the sum of these. So it would be n squared plus n times n minus 1 plus n times n minus 1 times n minus 1. And they've told you that the number of no red is 125. Exactly 125 have no faces painted red, like that. So there you go. Now you just have to solve this equation for n. So we've got n cubed minus n squared minus n minus 1 n and minus n minus 1 times n minus 1 is equal to 125. And we can probably factor an n from here, and that would give us n squared minus 1. If you factor out an n to the power of 2, it would give you n minus 1. And this is just n minus 1 times n, and n minus 1 times n minus 1 like that, equals 125. If you factor out the n minus 1 from everything, you're going to get n squared minus n minus n minus 1 like that. And therefore this becomes n minus 1, n squared minus n, so minus 2n plus 1. And this looks like it can factor. So we have n, 1 minus minus. Great, perfect. So this basically becomes n minus 1 cubed is equal to 125, and therefore n minus 1 is equal to 5, and therefore n is equal to 6. So that is what they're asking us in the question. Determine the value of n. So let's verify this now. N is equal to 6, right? So how many are total? N to the third, which would be 6 to the third, which is 216. And then how many were red? Well, n squared, which is 36, plus 6 times 5, which is 30, plus 5 times 5, which is 25, and that is 91. So how many were no red? Well, the total 216 minus 91, and that is 125, which is exactly what they told us in the question. All right, now let's move to 7b. In the isosceles trapezoid ABCD, AB is equal to CD is equal to x. The area of the trapezoid is 80, and the circle with center O and radius 4 is tangent to the four sides of the trapezoid. Determine the value of x. So let's label this the best that we can. First, do they give us anything here? They give us the area, and they also tell us that AB is equal to x and CD is equal to x. Then they've already labeled that for you, so that's good. So now I'm going to do is draw some lines in here to help us figure this question out. I'm going to draw a perpendicular from B down to the bottom, like that, and C down to the bottom like that. And I'm going to draw a line from the center, through the center of the circle, down to the bottom like that. And then I'll label these and hopefully you'll understand why I did that. So they tell you that the radius is 4, so that means the diameter is 8. So this whole thing is 8 from C all the way down to the bottom. All right? And from here to here, I'm going to label that Y. Okay? So immediately, before I do any more labeling, you'll see that this is a right triangle, and therefore 8 squared plus y squared is equal to x squared, like that. So that's the first relationship that we get. I don't know if we'll need it, but we have it. And then I will label this section right here Z. And therefore this is also going to be Z, because that's the same on both sides. And similarly, this is also Y. It's a symmetric diagram. Now what I'm going to do is I'm going to draw a line from the center to point A, like this. And a line from the center to the tangent point on the side there. So therefore these become right angles right there. This is a right angle and this is a right angle. And those two triangles, this one right here and this one right here, are pretty much identical triangles. So that means that from here to here is the same as there to there. All right? So that means from there to there is y plus z. Y plus z. So that means from here to here, it has to be x minus y plus z. Right? Because the whole distance was x. Okay? And now, I hope you see that when I draw one final line from B to the center, like this, that now we've got two identical triangles once again. You've got this one and this one that are identical. So therefore, this side here is also going to be x minus y plus z. All right? So now we have everything that we need. So let's proceed with what they want in the question, which is the value of x. And we will do that by figuring out the area of the trapezoid. So the area of the trapezoid is going to be first this triangle, which is 1/2 base times height. The base is y and the height is 8. Then this rectangle in the middle there, which is of course length times width. The length is 8 and the width is right there, 2z, like that. And then finally this triangle right here at the end, and that will be represented by 1/2 base times height, which is y times 8. And they've told you that the area of the trapezoid is 80. So all of this equals 80. So this becomes 4y plus 16z plus 4y. And therefore this becomes 80 is equal to 8y plus 16z. Now where do we go from here? Well, the good news is we have this relationship. This and this. If you notice, if you look at that diagram, those are equal. So x minus y plus z is equal to z. So therefore x minus y minus z is equal to z, and therefore x minus y is equal to 2z, like that. So we substitute that into here. 16 times z, which would be x minus y divided by 2. And I think this will be able to solve the question. So this becomes 8x minus 8y. The y's cancel, So you're left with 80 is equal to 8x, and therefore x is equal to 10. And that is what they want you to figure out in this question.